Okay, let's dive right into this explainer and completely shatter pretty much everything you thought you knew about how your memory works. For the longest time, we've treated human memory like a dusty old filing cabinet, right? Like it's just this biological video recorder where we store past events, and we only open it up when we need to remember where we parked the car or what we had for lunch. But cutting-edge neuroscience is telling us a completely different, and honestly, a mind-blowing story. Your memory isn't just a record of where you've been, it's literally the engine of where you are going.
So, to understand this, we actually need to start with a huge biological mystery. How are humans able to invent, innovate, and constantly create totally new futures unlike any other animal out there? I mean, think about it. If you look at our physical place in the world, we really aren't the strongest, we aren't the fastest, and we're definitely not the most numerous. Insects have us beat by an absolute landslide in sheer numbers alone. Yet we're the ones who have built global civilizations, cured diseases, and literally walked on the moon. What gives us this unparalleled ability to look at our current reality and imagine something completely different?
Well, the answer is hiding right inside our brains. Specifically, in a fascinating process that science, frankly, just misunderstood for decades. Deep inside your brain is this tiny, seahorse-shaped structure called the hippocampus. And for over half a century, the scientific community was absolutely dead certain that the hippocampus was strictly the memory department. If it got damaged, you couldn't form new memories. End of story, right? Actually, scratch that. The plot twist here is wild, because it turns out this structure is actually the biological engine of your imagination.
Let's look at this landmark study from 2007 to see how this flipped the script. Researchers brought in people with amnesia caused by damage to their hippocampus and gave them this exact prompt. They just asked them to visualize a completely fictional scenario, a white sandy beach, a beautiful tropical bay. And shockingly, the patients found it almost impossible to imagine new, logical scenarios. They couldn't construct the scene in their mind's eye at all. Think about the implications of that. If the hippocampus was only for remembering the past, why would damaging it completely destroy your ability to imagine a made-up future? This was a massive, game-changing turning point in neuroscience.
Here's the massive takeaway. The hippocampus isn't just a filing cabinet. It actually uses your memories as the raw materials to actively construct and simulate the future. Let's think of your memories like a giant bin of Lego bricks. The hippocampus doesn't just keep the fully built Lego castle of your past sitting on a shelf. It rips those experiences down into individual bricks, the people, the places, the feelings, and uses them to build entirely new, imaginary structures. It lets you test out what-if scenarios in your head before you ever actually do them in real life. So memory and imagination, they aren't separate systems at all. They are literally two sides of the exact same biological coin.
Now, here's where things get super counterintuitive. You'd probably assume your brain works the absolute hardest when you're laser-focused on a task, right? Well, it turns out that when you just zone out, this amazing thing called the default mode network kicks into gear and syncs up with your hippocampus. In our modern hustle culture world, we kind of feel guilty when we aren't being productive. But when you're just staring out a window or letting your mind wander in the shower, your brain is doing some seriously heavy computational lifting. The default mode network lights up, talks intimately with the hippocampus, grabs those memory Lego bricks, and just starts running these wild, incredibly creative simulations of the future.
To put that into perspective, let's look at the electrical signals in the brain, known as sharp wave ripples. When you're awake and actively engaged in doing something, your brain waves follow a pretty steady rhythm. But during deep rest or sleep, you get these massive, rapid spikes in electrical activity. These ripples are the physical proof of your brain replaying past events at incredibly high speeds, like up to 50 times faster than the actual experience. So zoning out is definitely not a screensaver mode. It's your idle brain working incredibly hard behind the scenes.
And you can actually map this simulation engine working in physical space. Researchers hooked up sensors to rats running through a physical maze. While they were running, their brain cells fired in a very specific sequence to map out the physical space. But during rest, something incredible happened. The resting brain compressed and replayed the exact same physical maze sequences, sure, but it went further. It generated entirely new, completely unexperienced paths. The resting brain was literally simulating new ways to run a maze the rat had never even tried. It's testing out those future what-ifs. This right here is the biological root of planning and innovation.
So, if we pop the hood and look at the actual wiring of this simulation engine, we see that the hippocampus is not just some uniform blob. It is highly organized, sophisticated biological hardware made up of subnetworks with very specific jobs. To understand how we actually pick which imagined future is the right one, we need to zoom in on two very specific areas of this neural wiring, the CA3 and CA1 networks. Okay, think of the CA3 network as your brain's biological VR headset. It's got these massive looping connections that let it just throw a million ideas at the wall and simulate endless future possibilities. It simulates everything. But obviously, if we acted on every crazy scenario our brain cooked up, we'd be in real trouble. Enter CA1. CA1 is your inner critic. It coldly evaluates all those wild CA3 simulations and asks, okay, but will this path actually lead to a reward? Together, this is the simulation selection model. Your brain dreams up the possibilities, picks the absolute best outcome, and then guides your behavior.
So what does this all mean for us? It means daydreaming is absolutely not a bug in your system. This whole neurosimulation process is the core biological foundation of human creativity. Your ability to remember the past was never just about nostalgia. It evolved so you could break your history down, hand those pieces over to your hippocampus, let your default mode network run wild while you rest, and use CA3 and CA1 to simulate a better future. That's your built-in innovation engine. It's the literal reason we can step back from a tough problem and suddenly have a eureka moment out of nowhere.
I want to leave you with a pretty provocative question. If innovation literally requires simulation, when was the last time you gave your brain permission to do absolutely nothing? We live in a world that constantly demands our attention. We scroll on our phones the second we're waiting in line or sitting on a train. But every time we do that, we are starving our default mode network. We're stopping our hippocampus from firing those sharp wave ripples and simulating brilliant new ideas. So, if you want to be more creative, more innovative, and solve problems better, maybe the absolute best thing you can do is just put the phone down, stare off into space, and let your amazing biological simulation engine do exactly what it was built to do.